Hi, welcome to Electrical Info YouTube channel. Subscribe our channel and share. Today we learn about MCB, Miniature Circuit Breaker Construction. Introduction to MCB. The miniature circuit breaker, MCB, plays an important role in providing overcurrent protection and a disconnect means in electrical networks. Recent advancements in circuit breaker technology has increased breaker performance and protection. A breaker is a device designed to isolate a circuit during an overcurrent event without the use of a fusible element. A breaker is a resettable protective device that protects against two types of overcurrent situations. 1. Overload. 2. Short circuit. Next we learn about MCB construction details. Thermal, magnetic trip units. Current limiting breakers use an electromechanical, thermal, magnetic trip unit to open the breaker contacts during an overcurrent event. The thermal trip unit is temperature sensitive and the magnetic trip unit is current sensitive. Both units act independently and mechanically with the breaker's trip mechanism to open the breaker's contacts. Overload protection. The thermal trip unit protects against a continuous overload. The thermal unit is comprised of a bimetal element located behind the circuit breaker trip bar and is part of the breaker's current carrying path. When there is an overload, the increased current flow heats the bimetal, causing it to bend. As the bimetal bends, it pulls the trip bar, which opens the breaker's contacts. The time required for the bimetal to bend and trip the breaker varies inversely with the current. Because of this, the tripping time becomes quicker as current increases in magnitude. Overload protection is applicable to any installation, conductor, or component which can be subjected to low magnitude but long-time overcurrents. Note: low magnitude, long-time overcurrents can be dangerous because they reduce the life of the electrical installation, conductor, and components, and if left unchecked could result in fire. Next we learn about magnetic trip units, short circuit protection. The magnetic trip unit protects against a short circuit. The magnetic trip unit is comprised of an electromagnet and an armature. Components of a magnetic trip unit. When there is a short circuit, a high magnitude of current passes through the coils, creating a magnetic field that attracts the movable armature towards the fixed armature. The hammer trip is pushed against the movable contact and the contacts are opened. The opening of the breaker's contacts during a short circuit is complete in 0.5 milliseconds. Next we learn about arc runners, arc chutes. The arc runner and arc chute limit and dissipate the arc energy during the interruption of an overload or short circuit event. During an overload or short circuit event, the contacts of the breaker separate and an electrical arc is formed between the contacts through air. The arc is moved into the arc chute by running the arc down the interior of the breaker along the arc runner. When the arc reaches the arc chute, it is broken into small segmented arcs. The segmented arcs split the overall energy level into segments less than 25 V. Each 25-volt segment does not have a high enough energy level to maintain an arc, and all energy is naturally dissipated. Next we learn about breaker curves. Thermal trip unit, region 1. The first sloping region of the breaker curve is a graphical representation of the tripping characteristics of the thermal trip unit. This portion of the curve is sloped due to the nature of the thermal trip unit. The trip unit bends to trip the breaker's trip bar in conjunction with a rise in amperage, temperature, over time. As the current on the circuit increases, the temperature rises, the faster the thermal element will trip. Example using the curve below. If you had a 10A breaker and the circuit was producing 30 amps of current, the breaker would trip between 2 seconds and 1 minute. In this example you would find the circuit current on the bottom of the graph, multiples of rated current. The first line is 10 amps, 10 amp breaker x a multiple of 1, the second line is 20 amps, 10 amp breaker x multiple of 2, and the third line is 30 amps, 10 amp breaker x multiple of 3. Next you would trace the vertical 30A line up until it intersects the red portion of the breaker thermal curve. If you follow the horizontal lines, on both sides of the red curve, to the left you will see that the breaker can trip as fast as 2 seconds and no slower than 1 minute. Magnetic trip unit, region 2. This region of the breaker curve is the instantaneous trip unit. MCB, miniature circuit breaker's instantaneous trip unit interrupts a short circuit in 2.3 to 2.5 milliseconds. Because of this, the curve has no slope and is graphically represented as a vertical straight line. Example using the curve above. If you had a 10 amp breaker, the magnetic trip element would interrupt a short circuit between 10 and 30 amps, 10 amp breaker X multiple of 2 and 3, in 2.3 to 2.5 milliseconds. Breaker contacts, region 3. This region of the curve is the time required for the contacts of the breaker to begin to separate. The contacts will open in less than 0.5 milliseconds and is graphically represented by the bottom vertical portion of the curve.